Let's try this question. This is cosine 3x divided by 4 plus sine squared 3x. This seems like substitution question. I'm going to try to substitute u as sine of 3x. For the substitution, you need to differentiate both sides. The derivative of sine is cosine 3x times 3 times dx. So you guys notice why we took this, because cosine dx is already in the question. So cosine 3x dx can be replaced by du by 3. Let's try to make the substitution. Cosine 3x dx would be replaced by du by 3, 1 by 4 plus sine 3x was replaced by u, but this is square, so you're going to look at it as u square. Now this looks like 1 by a square plus u square du. The answer to that was 1 by a tangent inverse u by a plus c. Okay, so using that formula, we have this is equal to 1 by 3. Here, if you notice, a square here, right? A square is 2. So a will be what? 2. So the answer is 1 by 2 times tangent inverse u by 2 plus c. 2 times 3 is 6. The u is not u, right? We have to answer in terms of x. So u is replaced back, not 2x, sorry, as sine of 3x divided by 2 plus c. That should be your final answer. Okay, so one more time, when you have something like this, we first need to do substitution. By substitution, we can use the integration of inverse trigonometric functions rule. Let's look at this question. This does not look like any of our formulas. So the first thing I'm going to do is whatever is here is under the square root, I'm going to write it separately. I'm going to try to make it perfect square. Okay. How do we make perfect square? Look at the steps 1 carefully. I'm going to take negative out. This is going to look like x squared minus 4x. Okay. 3 minus. Now here on the side, I'll show you. I'm going to look at the coefficient of x, which is what? 4. I'm going to divide that by 2. So what do I get? 2. I'm going to square it. So 2 square will be what? 4. I'm going to add this number and subtract this number. Okay. Let's look at one more time. This looks like 3 minus. I'm going to keep this inside this portion here, but that negative 4 I'm going to bring out. So negative x squared minus 4x plus 4, negative negative plus 4 outside. Okay. 3 plus 4 is 7 minus. Now this part here is the square of x minus 2. If you remember, let's write the rule here. A minus b whole square is a square minus 2ab plus b square. So that's why this looks like x minus 2 whole square. So what I'm trying to say here is this part inside can be replaced by this. Let's write it down. Integral. This technique is called making perfect square technique. Okay. Dx by square root of 7 minus x minus 2 whole square. Now let's see which formula does this look like. This is a little similar to dx by square root of a square minus x square. That's sine inverse of x by a plus c. Okay. In this question, in place of a square, what do we have? 7. So a is square root of 7. But in place of x, what do we have? X minus 2. As long as x's coefficient is 1, we should directly be able to apply the formula sine inverse of x minus 2 by root 7 plus c. So your answer should be this. But this doesn't come directly, okay? We first need to see how this can be converted into this using the perfect square formula, okay? But once you have that, you can use the inverse trig integration formula. Let's practice a different kind of a problem. Here we have an exponential function on the top. E the power is arc sine. Arc sine we know is sine inverse. And in the denominator we have square root of 1 minus x squared. This question looks more complicated unless we make a small substitution. So I'm going to make my substitution as u is equal to arc sine x. If you don't like looking at arc sine, this is basically sine inverse of x. Okay. So for making the substitution, we are making this substitution. For making that, we need to differentiate. What is the derivative of sine inverse? 1 minus x squared dx. Now you guys notice that that was my clue. This was already sitting here in the question, right? So whenever you make substitution, some format of the derivative should already be sitting in the question. So dx by this portion can be replaced by du. Let's make the substitution. Integral e the power u. This whole thing is du. What's the integral of eu? It's just eu plus c. But we get to put u back, arc sine of x. So once you make the substitution, this is actually a simple question, okay? But you need to practice making substitution and know the derivative of inverse functions here. Let's do one more practice problem. E the power x by 1 plus e the power 2x. Again, it's going to be tried using substitution. We're going to substitute u as e the power x. What's the derivative of that? E the power x dx. So that's already here in the question. So that part's going to be replaced by du. Ex dx is replaced by du 1 by. This is e the power 2x. Think of e the power 2x as e the power x square. So basically that can be replaced by u square. Now once we have that, we see that this looks like formula of 1 by 1 plus u square du, which is tangent inverse u plus c. So the answer for this should be tangent inverse u plus c. U can be replaced as, what was u again? E the power x plus c. Let's practice another question with substitution requirement, but also the integration rules of inverse trigonometric functions. Here I see there's an arctan square, and I remember arctan's derivative is 1 by x squared plus 1, which is already kind of sitting. So that gives me a clue to substitute u is equal to arctan x. If you don't know what that means, that is tangent inverse of x. When I differentiate that, that's 1 by 1 plus x squared dx. And that part is already sitting in the question. So we can replace this green part by du, and arctan we replaced it by u square. Now we know the power rule. Power rule, x to the power n tx is x to the power n plus 1 power add divided by new power plus c. So this will become u to the power 2 plus 1 3 by 3 plus c using the power rule. U have to be substituted back as arctan of x cube by 3 plus c. That should be your answer to the given integral.